a couple of the problems from the previous two homework assignments, just to make sure that we're on the right track with regression lines, and then also with our squared values and our residual plots. So this problem here, I selected, this is actually from section 2.6. But it was problem number 6, the one where they talked about in professional soccer, it's all about scoring goals. They said the number of goals that a team, or the number of games that a team wins is more strongly correlated with the number of goals that the team scores than with the number of goals the team surrenders. So in other words, they're saying the offense was more important than the defense. So in the year 2013, 2014, in that season, the mean number of goals per team, or sorry, I keep reading it wrong, the mean number of wins per team was 15.1, with a standard deviation of 6.73. They said the mean number of goals scored by a team for the entire season was 52.6, with a standard deviation of 20.62. And then they said the R value, the correlation between the two variables, was 0.889. Well, here's what they wanted us to figure out. They wanted us to figure out the equation for the least squares regression line. So that means we're trying to fit it to what we've been talking about, the A plus BX. But they want us to find that equation for predicting the number of wins from the number of goals scored. And that's kind of the tricky part. Since they said that they wanted to predict the number of wins from the number of goals scored, that means the number of goals scored should be our X values. The prediction on the number of wins then would be our Y hat value. So we had a formula as far as finding the equation, but in order to use that formula, we had to think about X bar, Y bar, standard deviation of X, standard deviation of Y. So we had to know which one's which. So when they gave us the information, the X's would be all the information dealing with the number of goals scored. So when they said the number or the mean for the number of goals scored was 52.6, what they're really saying was X bar was 52.6. They said the standard deviation was 20.62, so the standard deviation of X was 20.62. And then the information about wins would be our Y values. So they said that the mean number of wins was 15.1, so they're talking about Y bar for that. And the standard deviation was 6.73, so the standard deviation of Y was 6.73. And lastly, they told us the R value, that was 0.889. So we talked about the 5 pieces of information we need to find the equation. Well, now we know those 5 pieces. So let's go through and let's find the equation. Well, we started with finding the slope. So our slope, we decided, was the R value times the standard deviation of Y over the standard deviation of X. So for our problem here, the R value was 0.889 times the standard deviation of Y was 6.73 divided by the standard deviation of X, which was 20.62. So I'm going to punch that in and see what my value is. And I get 0.29 for my slope. Then we want to find our y-intercept. So the y-intercept was taking our y bar minus that slope we just found times x bar. So the y bar was 15.1. The slope we just found was 0.29. And x bar was 52.6. So I'll punch that in and see what I get. And for that, we get negative 0.154. So the equation for this situation would be y hat equals, our y-intercept was negative 0.154 plus the slope of 0.29x. So that was an example where we had the standard deviation of mean given to us, so we had to use the formulas. Remember, if they give us all the data points like they did early on in this section, like in problem number 1 and number 2, those you could punch into the calculator and find your linear regression from there. But probably the hardest part is figuring out which part's the x, which part's the y. And since they wanted to make the prediction from the goal score, that told me that those were all the x values that we're given. All right, then in section 2.7, one of the things we talked about was with a residual plot, deciding what it's actually telling us. So I'm not really concerned or as concerned about us being able to make a residual plot. It's more about what's that residual plot telling me. All right, well, if I look at this one here, this was problem number 3. But this residual plot here talked about looking at the text in one day. They made some sort of prediction, and they came up with this residual plot. Well, essentially, all I'm really looking at to make this determination, and they want us to determine whether the regression model was appropriate, basically I'm looking for, is there a pattern to this residual plot or not? Well, if I look at those residual, or all those points on the residual plot, they're pretty much spread out all over the place. So there's no real pattern to it. And in this case, that's a good thing. So what I would say is, yes, the linear regression was appropriate. Because there was no pattern to the residual. Plot. And again, the residual is errors, so we don't want predictable errors. So since all those were all over the place, we'd say, yeah, that's okay. That linear regression was the appropriate model. Well, if we compare that to number 4, if we look at number 4, we kind of have more of a pattern. If I were to follow along to my points, it's not an exact pattern, but it kind of has this U shape to it. Well, since I do have a predictable pattern, now my determination is no. The linear regression is not appropriate. And that's because the residual plot has a pattern. So it's kind of different than normal because the pattern's not good in this one, because we don't want predictable errors. Well, the second part of 2.7 was talking about the R-squared value. So in problem number 10, first of all, they said refer back to exercise 6. So exercise 6 had a situation tied to it. We didn't do the actual problem, but it had this graph here where they talked about the number of Mentos and the amount of cups that were of the Diet Coke that was expelled when we dropped those Mentos in there. But the problem itself we didn't have to do anything with it. All right, so problem number 6, we didn't do anything with it. They just wanted us to remember what the situation was, or see what the situation was. What we wanted to deal with, though, was this fact, the fact that we had an R-squared value of 0.602. And we wanted to try to figure out, all right, well, what's that telling me? Well, remember we said R-squared is another name for R squared is the coefficient of determination. In other words, what we're talking about is how much does the X value affect the Y value? And we're figuring that by a percentage. So if the R squared value is 0.602, what we're saying is 60.2% of the amount of Diet Coke expelled, in this case, was due to the number of Mentos. Or in other words, it was a percentage of how much the change or what was happening with the Y was due to what the X value was doing. So R squared, again, is our coefficient of determination. It's how we can put a statistical or a percentage on effect of X on the Y value. All right, hopefully that helps. Hopefully we're on the right track with those two sections, 2.6, 2.7. And hopefully the explanation, if you were having some trouble, clarifies things a little bit.